Here we are. Here we are at Algebra 10.5 factoring a squared plus bx plus c. This factoring is really doing FOIL backwards, and you're kind of blindfolded. So you'll need patience and a method to attack each problem the same way. If you use the same method every time, you should do okay in this section. So let's first start by doing this first problem, and I always ask myself the question, what two numbers multiplied together give me 15, my last number, while at the same time, if I add those two numbers, they'll give me 8. And that's really the only way you could do this if you ask yourself that question first. So that's the first question. Yeah, then what I do is I put an x here and an x here in my parentheses. And the reason I know that is because x times x is equal to x squared. Okay, so then I do a list of the numbers, 1 and 15. 15 times 1, 3 times 5, and 5 times 3. And you'll see later why I put both of 1 and 15 inverted back and forth with each other. Not ever, but one goes first and the second one. There's a reason to my madness, and you'll see that in a little bit, and probably even in the next problem. So if we did 1 times 15 is equal to 15, 1 plus 15 is 16, it's not 8, so it can't be that. So then I cross that out. I do the same thing to the other one, it's also not that. So let's try 3 times 5 is 15, plus 3 plus 5 is 8. So it has to be that one, and this is the method. I always write down the numbers that the possibilities of the n number could be in order for me to do this. So then I write 3 and 5 in here. Okay? Now, the question is if this number is positive, I know that it's either two negatives multiplied together or two positives multiplied together, and that depends on the middle number, which in this case, it's two positives multiplied together. And these are my factored forms. Now, if they want you to solve for x after this, and I don't know if they're going to have you do that in necessarily these, in this chapter, this unit, sorry. But yeah, actually they do have you do that. Then what you need to do is put x plus 3 is equal to 0, because this whole thing is equal to 0, and these two are equal to 0, just like in the previous unit. And x then can be equal to a negative 3. And in this case, it's x plus 5 is equal to 0, and x is equal to a negative 5. So then my x's, or my roots, or where the two numbers cross the parabola are, in this case, negative 3 and 5. And that's where those two cross the parabola. Let's go to example number 2. This one's going to be a little bit more challenging because, of course, it has some negative in there. It's not as straightforward as the other one. So let's ask ourselves the question, or let's ask ourselves the question of, first let me put my parentheses over here. It's the easiest thing to do. Well, I'm halfway there, right? I got half the problem. So what two numbers multiplied together give me 20, yet when I add them together or subtract them together, give me 9. So I have 20 times 1, of course, and 1 times 20. I got 2 times 10 and 10 times 2. I have 5 times 4 and 4 times 5. So let's do this first. If I put 20 in here, 20 times 1 is 20. That's correct. Does it equal to negative 9? No, it's not that one. So maybe it's a negative 20. No negatives are going to equal that. 1 times 20? No, it's not going to work. Let's go negative 2. And remember, if this is negative, this can make a difference. Negative 2 and a negative 10. Negative 2 times negative 10 is positive 20. That's correct. Are negative 2 plus a negative 10 negative 9? No, it is not. Can't be that one. These two have to be negative also, because I have a negative number right here. Negative 10 times negative 2 equals 20. Or equals 20, sorry. Is 10 minus 2. Negative 10 minus 2 equal to negative 9? No, it isn't. It's not these. Now, here it comes. Here comes the hard part. So these two are negative, right? So a negative 5 times a negative 4 is it's positive 20. What's a negative 5 plus a negative 4? It's negative 9. So there it is. Negative 5, negative 4 are both my factored sections on here, my factored parts. So I factored this. I've done this. You could always check yourself by going through FOIL and make sure that you got it right. In this case, x minus 5 is equal to 0. X is equal to 5. X minus 4 is equal to 0. X is equal to 4. So in this parabola, the roots are 5 and 4, in that they are both. That's where that parabola is crossing the x-axis. Okay, let's do a little harder one in this case. So now we're gonna go do my x, do my axis. Yay, I'm halfway done. Okay. So what two numbers multiplied together give me 18? So 18 times 1, 1 times 18. Let me think, what else? 9 times 2, and 2 times 9, and 3 times 6, and 6 times 3. For those of you who didn't notice, I changed this positive 18 to a negative 18 because I copied the problem wrong from the book. That's my problem. So, okay, let's try. And it's a negative, so one of these is going to have to be negative, and one of these is going to have to be positive in this situation, in order for this to work. And this is where the order between here and here is important. So negative 18 times 1 is a negative 18, but if I subtracted those, that becomes a negative 17. That's not right. What if I had the negative on this side, negative 18 times a negative 1? That gives me a positive 17. No. Both of these don't work on 18. 9 times 2, negative 9 times a negative 2 is equal to negative 18, but negative 9 plus 2 gives me a negative 7, and the inverse of the opposite is the same also, so that's not working. Okay, so this one looks more promising, so I'm going to say that let's do one of these as negative and one of these as positive. Okay, because we know that one has to be negative, one has to be positive. So if we do negative 6 times 3, that does give me a negative 18. But if I added these two numbers together, a negative 6 plus 3, that gives me a negative 3. And what I wanted here was a positive 3. So it cannot be in this order. It can't be in this order. It has to be, and notice that I am using an eraser, and you will have to use an eraser in this section, so don't use pen. Use an eraser so you can play with this. And so since I have my method to my madness, I'm going to put 3 and 6 in here. And let's see if this works out. X squared, negative 3x. This is my FOIL method here. I'm sorry, I'm not doing my proper FOIL. 6x, and this is a negative 18. I combine these two. X squared plus 3x minus 18, and that's the same answer as is up here. So my factored forms, or my factored form in this situation is definitely, oops, I went too far, I can't see that. X minus 3, x plus 6. And then if I set those equal to 0, the roots, or the section where this parabola crosses x is equal to a positive 3, and x is equal to a negative 6. And that's where those are the roots of this equation right here. Hope this helps out. It's a long video, but I hope you can challenge these problems in the book. Thank you very much.